Let's write our own ERC721 contract, also known as NFTs. First, we'll need to declare some interfaces that we're going to be needing for this contract. The first interface is a ERC165. We're also going to need an interface ERC721, and this will inherit ERC165. Our contract ERC721 will implement ERC721. So here I'll say ERC721 is ERC721. Now the functions inside here, we'll implement it later. The last interface that we're going to need is called ERC721 receiver. Inside this interface, we'll need to call this function on ERC721 received when we call the function safeTransferFrom inside ERC721. Okay, let's now write the code for ERC721. We'll first copy and paste some events that we need to implement. The events that we're going to need is transfer, approval, and approval for all. Next, let's declare some state variables. We're going to need to store the owner of each NFT, so I'll create a mapping from uint to address. Uint will represent the NFT ID, and address will represent the owner of the NFT. I'll make the visibility of this mapping internal, and then I'll name it _ownerOf. Next, we'll need to keep track of the amount of NFT that each address owns, so I'll create a mapping from address to uint. The address will be the count, and uint will be the count of NFT owned by the address. Again, I'll declare this as internal, and then I'll name it _balanceOf. The owner of the NFT might approve another address to take control of his NFT. So we'll store it in a mapping from uint to address. Uint will be the NFT ID, and the address will be the address that was given approval to spend the NFT on behalf of the owner. This will be internal, and I'll name it _approvals. Let's say that Alice owns NFT ID code 1 and approves Ball to spend the NFT on her behalf. Then uint will be NFT ID code 1, and the address will be address of Bob. This will tell that Bob has permission to spend NFT ID code 1. Perhaps the owner owns many NFTs. In that case, instead of getting approval for each NFT, we can give approval to a single address. So we'll say mapping from address. This will be the address of the owner of the NFT to another mapping, and then address. This will be the address that was given permission by the owner to spend the NFT. And then Boolean. True means that this address, the operator, will be able to spend the owner's NFT. And false means that the address that is stored here does not have permission to spend the NFT owned by this address. We'll make this mapping public and then name it is approved for all. Now the reason why I made this mapping public is because if I scroll up and expand the interface for ERC721 and then scroll down, you can see that one of the functions that we'll need to implement is called isApprovedForAll, which we've implemented here. Okay, so these are the minimal state variables that we'll need to store inside the ERC721 contract. Next, let's move on to functions. The first function that we'll need to implement if I open the interface for ERC721 is, since this interface is ERC165, let's implement this function. So I'll copy this function and then scroll down and then paste it here. And here we'll need to return true if the interface ID passed from the input matches the interface ID for either ERC721 or ERC165. So here I'll type return interface ID from input is either equal to type ERC721 dot interface ID or interface ID is equal to type ERC165 dot interface ID. Okay, let's implement the next function. What is the next function that we'll need to implement? Let's start with the easy ones, balanceOf and ownerOf. So actually, I'll copy all of this and then paste it here. And the function that we'll implement is balanceOf and ownerOf. The balanceOf function returns the amount of NFT owned by the owner. And the requirement here for ERC721 is that owner cannot be equal to address 0. So I'll type require owner not equal to address 0 with the error message owner is equal to 0 address, and then return balance of brackets owner. Okay, let's implement ownerOf. According to the specs, the call to function must fail if ownerOf token ID is the 0 address. So I'll say owner. Notice that the variable owner, I declared it here, so I don't have to declare inside here. Owner is equal to owner of token ID. Next, we'll check that this owner is not equal to the 0 address. So I'll type require owner not equal to address 0. And the error message owner is equal to 0 address. Okay, the next function that I'm going to implement is setApprovalForAll. So I'll cut this and then paste it here. By calling setApprovalForAll, you are setting the permission for operator to either take control of all of your NFTs or to revoke that permission. And this permission is stored in the mapping is approved for all. So I'll say is approved for all of the address for the first mapping will be the address of the owner. The next address represents the operator, and the last boolean represents the permission. True means that the owner has given the operator permission to take control of his NFT. And if it is false, this means that the owner has not given access or has revoked the permission for the operator to take control of his NFT. So is approved for all. The first address will be message.sender. The next address that you see over here will be the operator. And then the last parameter is approved. If this is true, this means that message.sender has given permission to operator to be able to spend his NFT. And if this is false, this means that message.sender has revoked all permissions for operator to spend his NFT. And then we'll emit the event emit approval for all. What are the parameters that we need to log? Owner, operator, and approved. So owner, message.sender, operator, and approved. Okay, that completes the function setApprovalForAll. Next, let's work on a similar function called approved. So I'll cut this, scroll up, and then paste it here. The approved function gives permission to the to address to take control of token ID. The caller of this function will either have to be the owner of token ID or has permission to spend the token. So first, we'll get the address of the owner. Address owner is equal to underscore owner of token ID. Next, we will check the permissions. So say require either message.sender is equal to owner or the owner of the token has given message.sender permission to spend the token. So is approved for all owner from the owner to message.sender. If both of these conditions are false, then we'll say that the error message is not authorized. Next, we'll set the approval for the token ID. So type approvals of token ID is equal to the to address. Here we're saying this to address has the permission to spend token ID. And then lastly, we'll emit the event approval. Let's scroll up and see what parameters we need to log. Approval, owner, spender, and the token ID. Owner, spender will be the to address, and token ID, token ID. Okay, that completes the function approved. Let's move on. The next function that I want to implement is getApproved. So I'll cut this and then paste it here. This function will return the address of the approval assigned to token ID. So what we're returning is the address stored for approvals for token ID. Now there is an additional requirement for this function that the owner of token ID must exist. So we'll say require owner of token ID should not be equal to address 0, else the error message token does not exist. And then we'll return underscore approvals of token ID. Okay, the next function that we're going to be working on is transferFrom. Now notice that there are two variations, and inside it there's going to be some code logic that we'll be able to reuse. So first, I'll implement an internal function. I'll implement an internal function called function underscore is approved or owner. This function will take in three inputs: address of the owner, address spender, and uint token ID. This function will be internal, view, returns, boolean. What this function does is check whether spender is owner of token ID or whether the spender has permission to spend the token. So we'll type return either spender is equal to owner, or the spender is an operator, is approved for all from owner to spender, or spender is approved. Spender is equal to underscore approvals of token ID. Okay, that completes the internal function is approved or owner. The next function that I'm going to implement is transferFrom. And then later we'll use this transferFrom function inside safeTransferFrom. So paste the code here. Since we're going to be calling this function inside safeTransferFrom, I'll change external to public. This function will transfer the ownership of NFT from to the address for the token ID. So first we'll require that from is equal to owner of token ID with the error message from is not equal to owner. We also need to check that the address 2 is not the 0 address. Require 2 is not equal to address 0 with the error message 2 equals 0 address. Next, we'll check the permissions. So we'll be calling this internal function is approved or owner. So require underscore is approved or owner. I'm gonna scroll up. From the first check, we know that the owner is equal to the from address. So owner will be from. The spender will be message.sender. So message.sender. And the token ID will be the same token ID. Token ID. If this check fails, we'll say not authorized. Once it passes these checks, next we'll actually transfer the ownership of NFT. So we're transferring from to. So first I'll update the balanceOf. BalanceOf from, we'll need to decrease the BalanceOf from by 1, so minus minus. And then we'll need to increase the BalanceOf 2 by 1, underscore BalanceOf 2 plus plus. We'll need to update the ownerOf, so ownerOf token ID. The new owner will be equal to the 2 address. Next, we'll delete the approvals by typing delete underscore approvals of token ID. And then lastly, we'll emit the event transfer. I'm gonna scroll up and see what parameters we need to log for the event transfer from to token ID. Scroll down from to token ID. Okay, that completes the function transferFrom. Next, let's implement safeTransferFrom. So this is a function similar to transferFrom. The difference is if 2 is a contract, then we'll need to call the function ERC721 receiver on ERC721 received. So scroll down. First thing that we'll do is call transferFrom. TransferFrom from to token ID. And then we'll need to check whether the 2 address is a contract. If it is a contract, then we'll need to call this function. So I'll copy this function and then paste it here. This is the function that we'll need to call. I'll put a comment for now. Then we'll call this function if the 2 is a contract. So I'll type require 2.code.length is equal to 0. This means that the length of the code stored at the address 2 is 0. So this will mean that the 2 address is either not a contract or it is a contract that was just deployed in this transaction. If 2.code.length is equal to 0, then we won't need to call this function. Otherwise, if the length is greater than 0, then we'll need to call this function. So if it is not 0, then we'll need to call ERC721 receiver on the 2 address. You'll need to call this function on ERC721 received. The address of the operator will be message.sender. From token ID will be token ID from the input. And call data, since we're not passing any call data, we'll pass in empty bytes. And this will return 4 bytes of interface ID. So we'll need to check that the interface ID that was returned is equal to ERC721 receiver.on ERC721 received dot selector. If either of these check fail, then we'll say that the error message is on safe recipient. And that completes the function safeTransferFrom. Next, let's implement safeTransferFrom. This is almost the same as the function that we just implemented, except that now as input it is passing some data. So I'll copy all of this, paste it here, and instead of passing empty data, I'll pass in data. Okay, I think I implemented all the function for ERC721. Let's try compiling it. I'll hit Ctrl S, and then I see some errors. So I'll open the compilation logs. And the first error I see is on line 68. Line 68. So as input, I passed in interface ID with a capital D, but inside the function, I'm using a lowercase d. So I'll fix this by lowercasing the d in the input. Okay, let me scroll down and see the other error is. It's also on line 68, so I think we fixed the error. Let's try compiling again, and the contract compiled. Now, before we move on, let's implement some functions that are useful but are not required for ERC721. The two functions that I want to implement is mint and burn, and these will be internal function. So I'll say function underscore mint. It will take in two parameters, address to, the address to mint the new NFT to, and uint token ID, the ID of the NFT to mint. This will be internal. And then we'll require that the to address is not the 0 address, not equal to address 0. Error message to is equal to 0 address. And we also require that the token ID to mint is unique. So we'll say require underscore ownerOf token ID is equal to address 0. If it is an existing token, then ownerOf token ID will not be equal to address 0. Otherwise, if it is new, then the owner of this new token ID will be equal to address 0. With the error message, token exists. Once it passes these checks, next we'll update the balanceOf and ownerOf. Underscore balanceOf to incremented by 1 and ownerOf to token ID is equal to 2. And then we'll emit the event transfer. This is similar to ERC20 transfer. Transfer from address 0 to token ID. Okay, let's implement the burn function. Function underscore burn uint ID internal. First, we'll check that the token exists. So I'll say address owner is equal to ownerOf token ID, and then check that the token exists by checking that the address owner is not equal to address 0. Require owner is not equal to address 0. With the error message, token does not exist. Once we know that the token does exist, first thing that we'll do is update the balanceOf, decrease it. So balanceOf owner minus minus. Since we're destroying this token, we'll delete the ownerOf. Delete underscore ownerOf token ID, and then also delete all approvals associated with this token. Delete approvals of token ID. And then we'll emit the event transfer from owner to address 0 token ID. The last part of this video is to create a custom NFT using this contract as the base contract. So scroll down and then say contract my NFT is ERC721. To mint a new token, we'll create a function called mint, and then address to uint token ID. This function will be external, and then we'll simply call the internal function underscore mint that we just wrote over here. So underscore mint to token ID. Next, we'll implement a function to burn the NFT. So function burn uint token ID external, Then we're going to be calling the internal burn function. But before we do that, we want to check that message.sender is the owner of token ID. So say require message.sender is equal to underscore owner of token ID. Error message not owner. And then call the internal function burn with token ID. And that completes the simple contract for ERC721 and a custom MyNFT.